DGI Geoscience Inc. Borehole data with a purpose. DGI Geoscience Inc. was founded in 1997, providing the first commercial service offering of hard rock wireline logging in Canada. Since inception, DGI has traveled the globe, providing downhole logging services worldwide, 365 days a year in all climate extremes. Rock physical properties logging has been used for over 100 years to characterize rocks by their non-visible properties. This allows rock units to be identified and contacts located with more certainty than purely visual analysis. The quantitative data from physical properties logs can predict core lab results with rapid availability and entire hole coverage, even in non-core holes. Physical property logs also can be used to refine surface geophysical survey interpretations with data in the third dimension. In addition, certain physical properties technologies have the ability to locate off-hole anomalies that may not have been intersected by boreholes. Physical property logging can be done in 3 different configurations. All surveys can be conducted in the downhole configuration, which produces a high-resolution, near-borehole environment. Certain properties can measure off-hole anomalies, enabling detection of ore bodies that were not intersected by the borehole. Still other technologies can be acquired in cross-hole arrays to produce a geophysical cross-section to image anomalies between holes. DGI's most common physical property logs can be divided into 4 categories. Of the electrical measurements, the combined induced polarization resistivity probe is the most common and can be run in both downhole and crosshole arrays. Inductive conductivity provides similar information to resistivity, only it can be run through casing, through air, or non-conductive fluids. Spontaneous potential is a passive measurement of electrical fields set up at mineral and fluid interfaces and is often used for stratigraphic analysis. Density measures bulk density downhole, including the rock and pore space. Neutron porosity measures fluid-filled pore space and can be combined with density measurements to calculate dry weight density. NMR porosity is a relatively new technology that measures porosity and pore size from which permeability can be estimated. Acoustic P and S wave velocity is used to identify lithologies, interpret seismic surveys, and, with density, calculate rock mechanical properties. Natural gamma measures the naturally occurring radiation from the rock, and spectral gamma analyzes the radiation frequency to determine elemental concentrations of potassium, thorium, and uranium. Magnetic susceptibility measures the total magnetic field strength of rocks, and magnetic field mapping measures the orientation of magnetic fields associated with ore bodies, which can be used for vectoring. Many of these probes can be stacked for simultaneous acquisition, limiting the amount of rig time necessary to collect multiple data sets. Shown here are examples of induced polarization resistivity surveys acquired in downhole and crosshole configuration. Induced polarization surveys are often used for sulfide exploration, especially disseminated deposits. Shown to the left is a downhole magnetic susceptibility log compared with magnetite assay values produced by a lab weeks later. To the right is a schematic representation of magnetic field mapping showing how magnetic field direction can be used to vector towards magnetic ore bodies. Shown here is a natural gamma log and potassium, uranium, and thorium concentrations from spectral gamma data with color-coded lithology classifications. Different lithologies have different ratios of the 3 elements. For example, the rhyolitic lithologies have high uranium and low thorium, while the dioritic lithologies have the opposite. Here are examples of other physical property logs showing unique responses to each section of the borehole. The combined lithology, alteration, and physical properties log plot here shows the value of physical properties for core logging. The lithology contrast at 2125 feet correlates well with the large gamma spike, and the lithology contrast at 2475 feet correlates well with the magnetic susceptibility spike. Furthermore, the gamma log is showing a zone from 2275 to 2330 feet that is not reflected in the lithology or alteration log. Physical properties can be used to define horizons that can be correlated from hole to hole. Data can be analyzed quantitatively to define lithologies and rapidly predict assay and core results with entire hole coverage, even in non-core holes. Shown to the right is a surface geophysical survey showing the actual geology and the geophysical model based on the surface survey alone. After downhole logging to gain data in the third dimension, the model has been refined to render a much more accurate picture of the actual geology, even resolving 2 new targets. These are just some applications of physical properties logging. If you would like to discuss your project and how physical properties logging can help, please contact us. DGI Geoscience Inc. Borehole data with a purpose.